Which of the following best defines a Banach space? A normed vector space that is complete with respect to the metric induced by its norm. In a Hilbert space H, the Riesz representation theorem states that every continuous linear functional f in H star can be written as: there exists a unique y in H such that f of x equals the inner product of x and y for all x in H. Which statement is the open mapping theorem for Banach spaces? A surjective bounded linear operator between Banach spaces is an open map, sends open sets to open sets. What does the uniform boundedness principle, Banach-Steinhaus, assert for a family Ti of bounded linear operators on a Banach space X? If for each x in X, supremum over I of norm Tix is finite, then supremum over I of norm Ti less than infinity. The operators are uniformly bounded. Which of these is a correct formulation of the Hahn-Banach theorem, extension form? Given a sublinear functional P on a vector space and a linear functional f on a subspace dominated by P, there exists an extension of f to the whole space still dominated by P. Let T x to x be a bounded linear operator on a Banach space. The spectrum, sigma of T, is defined as the set of scalars lambda for which T minus lambda I is not invertible, bounded inverse does not exist on X. Which property characterizes a compact operator K between Banach spaces? It maps bounded sets to relatively compact sets. Their closure is compact. In a Banach space X, weak convergence of Xn to X means for every continuous linear functional f in X star, one has f of xn converges to f of x. The Hahn-Banach theorem guarantees which of the following extensions: any bounded linear functional defined on a subspace can be extended to the whole space with the same norm. Which of the following is true about the dual space X star of a normed space X? It is the space of all continuous linear functionals on X, itself a Banach space under the operator norm.